Okay, when you see a square root, you take what's underneath the square root. Only what's underneath the square root. Any numbers in front or behind it do not affect your domain. Take what's underneath the square root and set it greater than or equal to 0. Go ahead and solve that inequality for x. You would subtract 4, divide by 3. So you should get that x has to be greater than or equal to -4/3. And the reason why, again, if you take the square root of -1 in your calculator, if you try to type in square root of -1, it says domain error. You cannot take the square root of a negative. So the smallest number that I can put underneath the square root without it being negative is -4/3. This is as low as I can go, and then I got to start. I can't go any lower. So my domain is -4/3 to infinity. That would be my domain for part A. Bracket on the -4/3 because you can take the square root of 0. The square root of 0 is 0. All right, part B. Does that have a red light? Who says yes? Who says no? It's no. It does not have a square root. It has a square, but a square root is a red light. It also does not have a denominator with a variable in there. So my domain is -infinity to infinity. That's your answer to part B. It's all real numbers. We don't have a red light. For part C, we do have a red light, and that's an X in your denominator. So I need for you to factor this down. Let's go ahead and factor it down. The denominator, that factors down to x plus 4 times x minus 4. Now we're going to set both of these equal to 0. So x plus 4 cannot equal 0. X minus 4 cannot equal 0. So x cannot equal -4 or +4. So it's optional. You don't have to do this, but I am going to put this on a number line so you can see it visually. So I have -infinity to -4. That's my first piece. And then in between -4 and 4, and 4 to infinity. There's 3 pieces of the domain. So you would say your domain for part C is -infinity to -4. We don't have any brackets because it cannot equal 0 in the denominator. So no brackets, all parentheses. And that would be your final answer. Why is not? I didn't hear you. I'm sorry.
Why is not x equal to 4 x equals 4?
So in your calculator, I want you to type in 5 divided by 0. And what does it say? Error. You cannot divide by 0. Now, if you type in your calculator the square root of 0, you can take the square root of 0, but you cannot divide by 0. So if I put a -4 right here, then that's going to give me 0 because -4 squared is 16. 16 minus 16 is 0. And if I put a +4 here, 4 squared is 16. 16 minus 16 is 0. These two numbers will cause my denominator to be 0, which is an error. You cannot divide by 0. Yes. So if you had, for example, if I gave you an example where it says D equals, if question D, and we'll probably do one like this on Friday. If it said f of x equals 4 divided by the square root of x minus 7, then I would say x minus 7, not only does it have to be positive, but it also can't equal 0. So it would just be x minus 7 is greater than 0 instead of greater than and equal to 0. But we'll talk about that more on Friday. All right. So 2.3 is where we are now in your notes. 2.3 is properties of functions. Homework 8 is due next Tuesday. We're actually going to do things a little backwards. We're going to start with example 2. We're going to skip over example 1 and talk about that Friday. Homework 7 is due Thursday, tomorrow. So let's go ahead. We're going to go all the way to example 2 and glue down example 2 in your notebook. So we're looking at this graph. Go ahead and add arrows to the graph. I meant to do that. So I'm going to add an arrow here and here. On the left arrow, because we're talking about the x values. When we talk about increasing, decreasing, we're saying as x goes from negative infinity to positive infinity, what is y doing? So my x value on the left is negative infinity, and my x value on the right is positive infinity. And your y value can do one of three things. It can either increase, which I'm just going to say INC. It could decrease, or it can stay constant. So what we're writing is the intervals. So when you look at the screen, see how I have my laser there, starting at negative infinity. Everybody look at the screen. What is my laser doing? Is it going up or down? So from negative infinity until I get here, what is x equal right here, though? Not y. You're always talking about x. What does x equal? 1. So from negative infinity to 1, the interval or your y value is increasing. So this is what you just told me, is that from negative infinity to positive 1, the y value is increasing. And then when we get to 1, from 1 to 2, it's staying constant. Y is constant. So that 1 to 2, and this is an interval, not an ordered pair. We're saying between x is 1 and x is 2, y is staying constant. And then starting at 2, what does it start to do? From 2 to 3, what is it doing? Decreasing from x is 2 to x is 3. So between x equals 2 and x equals 3, it decreases. And then lastly, when you get to 3 and all the way to positive infinity, what is it doing from 3 to infinity? Increasing. And that's it. You're just looking at a graph and telling me between what intervals of x does it increase, decrease, or stay constant. When we look at the second graph is even easier because we have ordered pairs. I want you to add the negative infinity on the left arrow and positive infinity on the right arrow. And I want you to understand that the left arrow, it doesn't matter that it's pointing down. That has nothing to do with it. The left arrow, x is negative. The right arrow, x is positive. So the left arrow will always be negative infinity. The right arrow will always be positive infinity. And if it confuses you, you can also cross out these y values because you're not looking at y. We're only talking about x. So this graph does not have any constant intervals, so I'm only going to say increasing and decreasing. So again, when I trace the graph starting from the left, what is it doing between negative infinity? What is my laser doing between negative infinity and negative 3? Increasing. And then from negative 3 to negative 1, it decreases. From negative 1 to 2, it increases. From 2 to 4, it decreases. And from 4 to infinity, it increases. So if I were to highlight it, you can kind of see. So this is where the graph is increasing. So there's 3 places where it increased and 2 places where it decreased. All right, so before you glue down example 3, I have some definitions for you to copy down. Go ahead and copy down these 4 definitions. Absolute. Now, I'm not sure. Some books call it global, but an absolute global max is your highest point. An absolute global min is your lowest point. A local relative max is a hilltop or a peak. And the local relative min is a valley or a dip. So that's kind of my easy definitions for these 4 extremists. So I'll give you a moment to copy that down. After you copy that down, go ahead and glue example 3. ahead and look at these two graphs and identify these four extrema. So the first extrema, when we look at this first graph that you have, I'm just going to write on the actual graph. Absolute max and min. So absolute max, absolute min. Notice how this arrow, we have opposite arrows. One side is increasing and the other side is decreasing. So if you have an arrow pointing up, will you ever reach the top or highest point? No. And if you also have an arrow pointing down, it's never going to stop decreasing. So this graph never stops increasing or decreasing, which means it does not have a highest or lowest point. So it doesn't have any absolute or global extremes. Now, as far as your local, I'm going to just give myself some space here to write. As far as your local, you do have some hilltops or peaks. So right here, where I have these blue dots, this would be my local maxes. There's two of them. And where I put my green dot, these would be my local mins. So we're going to write those two blue dots as ordered pairs. So I would have a local max at -1 and +1. And then for my local min, that's a little harder to estimate. It's a little less than 0 and it's about -4-ish. I'm going to round it to 0. It's probably like -0.2 or something. But again, we're just approximating to the best of our ability. And the second one is about here, which is +2.5. And we can say that's about what? What do you want to call that point? -14. That sounds good. Let's go with it. So 2.5, -14. All right, now let's look at the second graph and do the same thing. Anybody need more time with the first one? Okay, I can give you another 30 seconds. All right, so we're going to do the same thing with our second one. I'm just going to write absolute max, absolute min, local max, local min. Okay. And then add arrows pointing down if you didn't already. So this graph does not have an arrow pointing up, so it does have an absolute max. The absolute max is your highest point. And would you agree that this point where I put this red dot, that is the highest point? So let's go ahead and list that. Now, your graph, I know it's not that great, but this is actually counting by twos. You probably can't see that. So we're going to say that that point, what do you want to call that red dot? I'll let you all name it. -2.8. All right, let's do it. It might be a little higher, but again, we're just trying to approximate it to the best of our ability. And we have another mountaintop or peak, and that's right here. That's not the highest though. So we're going to call that a local. The highest one is the absolute, and any other ones are locals. So the local max would be at about 1, 2. Now we don't have a lowest point because we have two arrows that are decreasing constantly. So for absolute min, we're going to say none. Now, do you see a dip or a valley in this graph? Yep. And we're going to call that the absolute, and that would be here, and that's the origin. So our last example that we're going to talk about is example 4 today, and that is rate of change. So I'll give you a moment, and then we will go to example 4. Does anybody remember another word that represents rate of change? Begins with the S.
Slope.
Slope. That's what we're going to find, the slope. All right, so take a moment. And I'm actually going to rewrite this formula because I do think this formula, this is the pre-calc way of saying it. But this is essentially saying m equals y2 minus y1 over x2 minus x1. It's the slope formula. So I'll give you a minute to copy that down, and then we'll work through that. So you don't have to write down both formulas. You can just write down the simplified one that I have, whichever way. Okay, so we have this function here. These two values in the bracket represent x1 and x2. So your first step is going to be to find h of -1 and h of +1. So I'm going to quickly substitute in a -1 in my function. And I'm going to do the same thing for +1. So use your calculators. Substitute in the -1, substitute in the +1. So this is my function here. This is my function. And these are my two x values. So I put a -1 in this function. And I put a +1 in. Because remember, to find the slope, you need 2 points. So -1, so let me see, +1 plus 2, 3, 6. So you should get 6 for the first one. 1 minus 2 is -1. -1 plus 3 is +2. So make sure that's right. So now we have two ordered pairs. So my ordered pair is -1, 6 and +1, 2. So what I'm going to do now is write this as an ordered pair. So when x is -1, y is 6. When x is +1, y is 2. So we have our 2 points. Label them x1, y1, x2, y2, and find the slope. So your rate of change is going to be, and it doesn't matter which point I called point 1 and which one I called point 2. So y2, 2 minus 6 divided by 1 minus -1. That would be -4 over 2 or -2. So this is my rate of change. This is my final answer that I'm looking for. So we figured out the rate of change between -1 and +1 on this graph is -2, which means it is a decreasing interval. So we have a part B, and then that's it. No. So our final answer is what I have highlighted. It's just -2. So using the same function, let's do it with with 2 more x values. Let's find the rate of change. So now you need to find h of 0 and h of 2. So that would be 0 squared minus 2 times 0 plus 3. And then 2 squared minus 2 times 2 plus 3. So who got 3 for both? All right, good. So now we're going to find our slope again. You probably already recognize what the slope is, but I'm just going to work through it. So it's 0, 3, and 2, 3. Because we figured out that when x is 0, y is 3. And when x is 2, y is also 3. So when we find our slope, the slope is going to equal 3 minus 3 divided by 2 minus 0, which is 0 over 2. So my rate of change is 0, or my slope.
But it becomes
Or it means it's constant. Good. So that's a constant interval. What I have highlighted in blue would be your final answer.